In this example, we're looking at applications of linear and exponential functions. This is going to look very similar to what you're doing already in your Math 142 class, but with linear and exponential functions, it's nice to see a little bit of stuff that you might have seen in something before. So we're going to just do an example here to kind of just reiterate the process. So in our first example, we have a candy company has a machine that produces candy canes. The number of candy canes produced depends on the amount of time the machines have been operating. The table shows the number of candies produced after so many minutes. So we have a table of the amount of candy canes produced. The time in minutes goes to 0 and the candies produced are 0. After 1 minute, there are 32. After 2, there's 64. And after 3, there's 96. We want to determine a linear equation for to model this situation, clearly indicate what each variable represents. The first thing we notice is that we are looking at candies produced and time. So it might make sense to use C for candies, and then function notation allows me to put in a C of T. That just means looking at the number of candies at a particular time. And so this is the number of candies produced, can't spell, and time T. Now we need to try to figure out what the formula would be for this. So what we notice is the difference from the first minute to the second minute is 32 minus 0. We produce 32 in the first minute and 0 in the 0 minute. That gives me 32. The difference from the 2 to 1, from 1 to 2, let's say, means that we had 64 minus and 64 in the 2 minutes minus 32 in the 1 minute, which also gives me 32. If we want to just check one more time, the difference in the 2 to 3 minutes, we had 96 in 3 minutes produced, 64 in 2 minutes to produced, and that again is still 32. So it looks like we're always having 32. And that actually is my slope because the difference here each time is just 1. So if we take 32 and divide by 1, that would actually be my slope. So when I also look at this, my slope is 32. My vertical intercept is where I started. I started at 0 time. There are 0 candies. So my vertical intercept is 0. So my formula is C of T is going to equal 32 times T. Now we're going to use this model to determine the number of candies produced in 20 minutes. So 20 minutes is my time. And so we're going to put T of 20 in. And that means everywhere I see a T, I'm going to put a 20. And then I'm just going to multiply 20 times 32. And that is 640 candies. We also might want to use this model to determine when the machine produces 160 candies. So now we know the number of candies is 160. What we don't know is the time. So we have 160 is equal to 32 T. And we can either solve this and find out what this is, or we can actually use a graph. Oops, sorry. So we can either use the graph or we can actually solve this ourselves. If we want to use a graph, then we just need to get into Desmos. So let me stop sharing for just 1 second so I can go get Desmos, and I'll go get Desmos open. and we'll see how to use Desmos for this. So when we go to use Desmos for this, we're going to go ahead and put both sides in there. And let me go ahead and start sharing again. So here is my Desmos up. And now what I've got is I'm going to put in, and actually I realized I should have shared a little bit more than that. So let me stop sharing for just a second. Let me share one more time. I'm going to just share the whole screen. So when I go back to my formula, I have 160 is equal to 32t. So we're going to put 160 for y or c in one side and 32t in for c in another spot. So my Desmos, what I'll do is I'll say c of t equals 160. And then I'll put c of t is equal to 32t. And what I notice is I don't see much. I see this sort of vertical line going here. I certainly don't see this anything else. I don't see much on this graph. That tells me I need to change my graph. And I got to realize that my graph right now goes from 0 to 6 in the y, but I want a y of 160. So that kind of tells me I need to change my window a little bit. So my x-axis may be okay. We're not positive about that, but let's just change the y-axis for the moment. We don't need to come all the way down to -6 because we know we've got number of candy canes. So I like to put -1 just so I see the 0 a little bit better. And then my y, I know I at least need to be 160. So let's go to 200. And now if I go back and look at my graph, I do see my red line. And if you don't like red, you can change the color by just clicking on it. That turns it off. But if you click and hold, you can get a different color. Let's say I use, oh, green's probably not a good idea either. Let's use black. And then I see my black line at 160. I see my other line, my blue line of 32t, and I see that they do in fact intersect here. And if I click on it, I can see my intersection point is 5 when my C of t is 160. So that tells me that my value is I will produce 160 candies when t is equal to 5 months. I'm sorry, 5 minutes, not months. I was going to say 5 months would be really long, but 5 minutes, because that's what my time is in. So put my 5 minutes, and this is why you always want to check these things and make sure that makes sense. So that's my answer. You can also solve this algebraically if you want. And what that means is you just get t by itself by dividing both sides by 32. So if I want to do this algebraically, I have 160 divided by 32 is equal to t, and you also get t is equal to 5. But you can also see how to do these things graphically. Graphs are wonderful pieces to use. You just have to change your graph a little bit so you can see things. All right, let's go to another example. In this example, the population of a small city is shown in the following table. So we have table 2, a table of a town's population. Year 2000, the population is 12,545. In the year 2001, the population is 15,269. In the year 2002, the population is 18,584. Assume that the growth is exponential. Let t equals 0 represent the year 2000. Let A be the initial population in 2000, and let B equal the ratio in population between the years 2000 and 2001. We want to write the equation of the exponential model for this situation and then round any decimals to 2 places. Make sure you define what your variables are you use. So we are looking at this. We notice that we have probably P for population, T for number of years. So P of T would be your population size in T years. So there I've just defined what my variables are because I've told you what everything kind of stands for here. Um, I'm noticing I'm gonna let B be that ratio of the population between those 2 years. So I gotta go find out what B is. So the first thing I need to do is take my 2 years of 2000 and 2001. 2001 was 15,269. 2000 was 12,545. And that's going to represent B. And so if I take out my calculator, that comes out to be 1.22. It also said to let t equal 0 represent the year 2000 and let A be that initial population in 2000. So that tells me my A is 1,200, it's like 12,545. The reason I'm using A's and B's is because I know that exponential equations have the formula A, P of t is equal to A times B to the t. So if I know what A and B are, I can just plug them into this formula. So I have that P of t is equal to 12,545 times 1.22 to the t. And I now have my formula. That's my model. Now, using this model, we're going to forecast the population in 2008 to the nearest person. So if the year 2000 is year 0, then year 2008 means my t must be 8 because we're 8 years from 2000. So P of 8 would be 12,545 times 1.22 to the 8. Taking out your calculator, plugging all that into your calculator, you're going to get 61,567 people. And I did round that to the nearest person. We also want to use this model to determine the nearest whole year in which the population will reach 50,000. So now we know what P of t is. P is the 50,000 equals in my model 12,545 times 1.22 to the t. So we just need to find out what t is. You can use logarithms to do this. We're going to go ahead and use the calculator. So to do this with my calculator or with Desmos, I prefer Desmos over the calculator a little bit. So we're going to go ahead and put these into the calculator. So again, we're going to use P of t is 50,000 as one side, and then P of t is equal to this equation is the other side into our Desmos. I'm going to go ahead and just delete these out. So I just can hit delete, X them out. Now I can type in that P of t is equal to 50,000. Don't put the comma in there because they will think it's something different. They'll think it's a list. So I didn't put the comma in there. And then P of t is also equal to, let's see, what was that? That was 12,545 times 1.22 to the, and to do the power, you can either just hit a caret. You can come down here to your keyboard and you'll see that you can actually use that for the power. So you can either hit the type the caret and it'll make a power, or you can press this arrow thing down here, the keyboard down here, that'll expand this, and then you can see A to the B. But we're going to use it, and it makes it into a power. And then we're going to put a T up there because we don't know what T is. And again, you don't see anything on your graph because we're going to have to change our window again. So let's go change our window again. I don't think we need negative Y values, but again, I like to have the -1 just so I can see a negative on there. But we know we need 50,000, so maybe 100,000 or maybe 60,000. Let's go 60,000. Let's not go too crazy. And now again, I look at this and I notice I can see where they cross. If you don't see where they cross, by the way, then it just means you have to change your y-axis. And so you could change your y-axis. I like again have that negative on there and maybe change this to 20 instead of 10. Just so you can see it better, but you can see it already, so you don't need to really do that. And now you can see where they cross is 50,000 is 6.9 years, or almost 7, 6.95 years. So we can come back here and we can say from this that it's t is equal to 6.95 years, which if you want to round that to 7, because they do one of the nearest whole year, so that would round to 7 years. And that means my year is 7 years from 2000, so it's year 2007.